Hello everyone. So today we are going to solve problem number 141, linked list cycle on LeetCode. So what we'll do in this problem is we have given the head of the linked list and we need to find if there is a cycle present in the linked list or not. So here we have given a head and we need to find if there exists any cycle present in this linked list or not. So here's first example 3, 2, 0, minus 4. So you can clearly see that there is a cycle present in this first linked list. So we need to return true. In the second example also we can see there is a linked circle present. So we return true. And in the third example there is no circle present. So we will return false. The constraints given here are the range of the list can go from 0 till 10 to the power 4 and the value of each node can go till 10 to the power 5. So how can we solve it? Let's first try to solve it using brute force approach. So what is the brute force approach here? We will start from the head of the linked list from 3. While we are traversing, we will keep on adding them in a set. So when we add 3, we will add it. When we reach 2, we will check if 2 is already present in the set or not. And if it is present, that means we are visiting it twice. Then we can say that yes, there is a link circle present, and if not, then there will be no circle present. So when we reach 2, first we will check and then we will add 2 to our set. Then we will reach 0. 0 is also not present in our set, so we will add it. Then we reach minus 4. Minus 4 is also not present in our set, so we will add minus 4 to our set. Then the next pointer will take us to 2 again. So this time when we check if 2 is already present in our set, we can see yes, this 2 is already present in our set. This means that there is a cycle in this linked list. So we need to return true. Then again same for here. We start from the head. We see that our set is initially empty. So we add 1. Then we move to 2. We check if 2 is present. 2 is not present. So we add 2. Then we again come to 1. And we see here that 1 is already present. It means that we have found a circle. So we return true here also. In the last example, our set is initially empty. We visit head and check if it is already present in our set, which is not. So we add 1 and then we hit a null pointer. That means there are no more elements present. So if we either terminate the linked list or we found again the same element, we will come out of the loop and we'll say yes that there was no cycles present, so we need to return false. So let's see quickly how to code this brute force approach. So for brute force, what we need a set of list node pointer type. Let's call it st and let's take a list node variable that will start from head. Let's call it current and it will start from head. So while this current is not equal to null, that means there are still some elements processed or the current has not become null. So then what need to do? First we will check if st dot find cu current is not equals st dot end. That means we need to check if this is already present in our set, and if this is the case, we simply need to return true. And if we check and it is not present, then what we need to do? We need to add this current to our set. So we'll do st dot insert current. Then we also need to move this current one step ahead. So we'll do current equals current next. And then if we come out of the loop using this null, when we hit this null, then we will say yes, we traversed the whole list and there was no cycle present. So we'll return false. Let's check if it is running. So sample test cases are passing. Let's try to submit it. So we can see we are getting a successful solution, but here we can see the time complexity is big of n, and also the space complexity here is big of n, because if there are no cycles present, all the elements need to be inserted in the set. That means our maximum time complexity can space complexity can go up to big of n. So for this approach, the time complexity and space complexity both will be big of n. So is there any better algorithm to solve this? So yes, there is. We can use the Flood's algorithm to solve this problem. So what a Flood algorithm is? So it's a standard algorithm to solve reduction of cycle in a linked list. So how does algorithm works? So let's first take our first example. 3 to 0 minus 4. You can say any arbitrary value. 3, 2, 1, 0. And 0 is connected back to 2. 3 is connected to 2. 2 is connected to 2. And 1 is connected to 0. So how this algorithm generally works is we take two pointers. Let's call one pointer a slow pointer and another pointer a fast pointer. Both will initially point to head only. So okay, this was the head given to us in the problem. So both will be pointing to head, slow and fast. Slow will move one step at each iteration, and fast will move two steps at each iteration. And what we need to check, if slow and fast both become equal or not. So initially they will be at same position, so we don't need to consider this position. What we'll do, we'll first move them, then we check if they ever become equal or not. So how will this move? Slow will move here at first step, and fast will move two steps. So one step this, then one step this. So fast will come here. Then in the next iteration, slow will become coming here. So now these are not out, and fast will move two steps. That is one step here and one step here. This will again come back here. Then in the next step, slow will move here one step, and fast will move one step, two step here. So now we see that they both reach at the same node. So we can say yes, there is a cycle present. So can is there a way to verify that this algorithm will always work or not? So let's take an example to make it more clear to you. So suppose we have a linked list like this. The values here are arbitrary, so it doesn't matter which values you take or not. Let's take a simple linked list. Okay, and try to connecting it this way. So initially our start slow and fast will be pointing at the head of the linked list. Okay. So It is obvious that if fast is moving twice the speed of the slow, fast will enter the loop first. It is quite clear. So what happens here? Fast will move two steps and slow will move one step. So now you see what is the gap between them. So the gap currently is 1. And we know this fast is moving twice, or you can say two steps at a time, and slow is moving one step at a time. So what will happen eventually is at each iteration, this gap will keep on increasing. So what happens in the next iteration? Slow will, let's take a different color. Slow will come here and fast will come here. Now what happens with the gap? The gap is of 2 units. Next what happens? Slow comes here and fast moves 2 steps. One step here and one step here. So fast moves here. Now the gap becomes of 3 units. Next what happens? Slow comes here, one step, and fast moves 2 steps. One step here, one step here. And now if we try to calculate the distance, it will be 1, 2, and this 3 and 4. So total 4 units apart. And in the next step, slow will move here and fast will move 1, 2. Fast will move here. So now the distance has become, if we take the longer distance that was increasing previously, so now the distance has become 1, 2, 3, 4, and 5. So now distance has gone to 5. And in the next step, this fast will come here and this slow will also come here. And our distance becomes 6, or we can say 0 also. So we see that our distance keeps on increasing at each iteration, and finally it will become equal to the size of the loop. That means it is guaranteed that eventually slow and fast will meet if there is a cycle present, and if there is no cycle present, obviously they won't meet. So we can say by confidence, yes, this algorithm always works, and we have also seen now a proof for this. So let's see how to code it. So the code also is very simple. Let me first reset it. So what we require was 2 pointers, slow and fast. So we'll take 2 pointers, slow and fast. Both of them will initially point to head of the linked list. So we say head equals head. Then we need to run a while loop till when, we'll see later. Then what we need is we need to first move them because initially they are already equal. So we first need to move them. So slow will become slow equals slow next. So this will move one step, and fast equals fast next next. So this will move 2 steps forward. And if slow ever becomes equal to fast, we need to return true. That means yes, we have found a loop. And after traversing everything, if we don't find a loop, we will return false. Now what should the terminating condition be? So we can see we are using accessing fast and fast next. So both of these values should not be null. We don't need to worry about slow here because slow will always be behind the fast. So we need to check 2 conditions. If fast is not equals null and fast next is not equals null, Also, we need to make sure that we first check this condition, then the second condition. This cannot be done the opposite way. That means you check fast next previous to fast. Because if you're trying to access the fast next, and if fast is already null, so this will give us an error. Now let's try to submit it. So it is accepted. Let's try to submit it. So it is submitted. Now let's analyze the time complexity. The time complexity will still be big of n, because if there is no loop, we have traversed the whole array. And what we have gained in this method is the improvement in space complexity, because now the space complexity has reduced to big of n, or you can say constant space. So yeah, this was today's problem. We solved it using brute force and optimal approaches both. So thank you and see you in the next video.